All right, so this support workshop is inspired by a bunch of support tickets that have come in around proxies. It seems to be that proxies can cause a lot of different kinds of networking issues depending on how they're used and what particular part of the network infrastructure that they're placed in. And often they're difficult to diagnose or replicate the issue, or even to understand what a proxy actually does. Like what's its function, how does it interact with scripts, and what other kinds of things that you need to look out for when proxies are in play. And so for this, this support workshop, we're going to look at how you can debug a proxy locally and try and replicate some of the issues that people might be seeing. We'll look at what configuring a proxy actually means. What does it actually set up? What settings does it actually change? And also look at potentially some of the edge cases or gotchas that you might need to look out for when diagnosing issues with proxies. So to start with, obviously we need a proxy, and for this, one of the easiest ways that I found to get a proxy up and running is to just run Squid as a Docker container. So this is a container created by Datadog. They're just a monitoring company, and it looks like the container that they've created is relatively up to date, and it certainly worked in all the testing that I wanted to do. And so this Docker command here creates a Docker container called Squid. It maps the port. So this is the port on my local box, and this is the port inside the container. In this case, they're the same, but actually I'm going to run a couple of different instances of Squid. And so we will bump this one up to make sure we don't conflict with any ports. We do have a volume mounting here, and this is so the logs generated by Squid are available on the local disk. And in this case, I've just created a directory on my C drive called temp squid, and that gets mounted inside the container as varlog squid. And we'll see the log files that get created there. And then this is the name of the container. And so I've actually run this 3 different times here. So I've got one here, and this is mounting 3128. I've got a second one, this is 3129, and a third one, which is, it's going to be 3130. And these are just different, these represent proxies that we'll use at different points in the network. And so we can see how they interact. So what do we even mean by proxies? There's a couple of different places where a proxy can be configured in Octopus, and it has different implications. So the main one, and the one we'll spend most time looking at, are the web proxies. And so for the Octopus server itself, this is done in the Octopus Manager, and this is configured through this dialog here, and you can see that I'm pointing to localhost and that port that the Docker image is exposing. And so this will result in network interactions from the Docker server itself going through this particular proxy here. For tentacles, they also have a web proxy. So in this case, I have let me go here. So in this case, I have a polling tentacle, and it's configured with a web proxy. And so this means that any outgoing network connections made by things like scripts or steps will be routed through this particular proxy here. And there's also, for tentacles, there's also a proxy that the tentacle itself uses to connect to Octopus. So in this case, on this second tentacle, I've set that up here. And the polling tentacle configures its proxy on the manager because it's establishing an outbound connection, so it knows how it's initiating that connection. And in this case, it's going to initiate that connection through a proxy on localhost on 3130, which is that third port that we set up on that third instance of the Squid Docker image. For listening tentacles, the proxies are actually defined on the target in here. So if we look in here, which I don't think I have a listening one, but it's a machine proxy. So this is just a dummy proxy here, and if you went ahead and set up a listening proxy in here, there is an option to configure the proxy that Octopus will use to establish that connection back out. And so these tentacle proxies are not, there's not a lot that they need to do. They're really just mediating the connection between the tentacle and Octopus. But once that connection is established and all the packets from between Octopus and the tentacle are going through it, it either works or it doesn't. There's not generally a whole lot of nuance into that connection. And so we won't focus too much on that today. One thing I will point out though is that if you're using Squid and you want to enable proxies for tentacles, you do need to go in and change some settings. So if we look at the squid.conf, just zoom in here. If we look at this file here, I've actually had to make two changes. SSL ports. Yeah, here we go. So the default configuration defines these two kind of groupings, SSL ports and safe ports. It lists the standard kind of ports that you might find for internet connections, but because tentacles have their own unique port, you do need to add the polling, the tentacle port here as a safe port and as an SSL port. So these two lines here are what I had to add to this configuration to allow a polling tentacle to reach through it into Octopus. That's just something to keep in mind. If you don't have those two settings, you'll actually get a 403 forbidden error in the logs, and the connection won't work properly. So I do have a tentacle set up talking through a proxy. Actually, the other thing I should point out is the host names can be a little bit tricky if you're working with Docker containers. So if I look here, so this is the tentacle that has the proxy set up for the polling for the tentacle itself. And what you'll notice is that I've actually had to say that I'm connecting to this host.docker.internal, even though the Octopus itself is just running on localhost. And that's because localhost inside a Docker container is different than localhost outside of a Docker container. But this address here is how the host, the main computer here that I'm running, is accessible from inside a Docker container. And so once I've configured this proxy to use a, once I've configured this tentacle to use a proxy inside a Docker container, for that proxy to reach back out again and hit my local machine, it has to use this address here. So those are the two things you need to be aware of when debugging with proxies inside of Docker containers. But the more interesting bit is there's this proxy here, which is the proxy used by the Octopus server itself. And this proxy here, the web proxy, which is the proxy used by outbound connections with scripts run on this particular tentacle. And so what does that mean to have a web proxy set up? And if we look here, there's a couple of different things that actually get set up when you configure a proxy, a web proxy. If I just zoom in a bit. So the first thing that gets set up are some environment variables, and that's those three here: HTTP proxy, HTTPS proxy, and no proxy. So these are standard environment variables that a lot of command line tools know to look for in order to configure themselves. This is set both for the any bash scripts as well as PowerShell scripts. Everything after these three is PowerShell specific, so there's no equivalent to all these for the bash scripts if you're running them. But in PowerShell, we do have this object here called Octopus Proxy, and that's an object that represents the configured proxy, and you can use that to manually pass it into a lot of PowerShell commandlets if they accept a proxy parameter. We then have the default web proxy being set up, and on the web request, and also on the HTTP client. And so what this means is that a lot of requests through like standard PowerShell and PowerShell commandlets will inherit the default proxy. And in PowerShell 7, or prior to 7 I should say, is the default parameter that is used for commandlets like invoke web request and invoke REST method. The proxy is set to a default parameter, and in this case it's just going to be that same Octopus proxy here. And so this means that if you run any scripts prior to PowerShell 7 that use these commandlets, the proxy is already set up as a default parameter for you. And so to verify that we are actually using a proxy, I'll just invoke web request here, and we can see how that traffic gets passed through the proxy itself. So this step here is running basically directly on the server. And so what that means is it's going to use these settings here. So this is the first proxy here, 3128. And that corresponds to the, actually I should show you the log files. So if we look in here, the temp squid, because I mounted that directory from the Docker image onto a local directory on my computer, we get these two log files here, and it's the access.log file that we often want to watch to see the traffic. And so you can see I'm just tailing the content of this file so we can see any new requests that are being made. So if I go ahead and run this, we'll see a couple of interesting things. Okay, so we can see the output of all those variables that we set up. So these are the environment variables. They have been correctly set to the address of my Squid proxy running in that Docker container. No proxy is interesting. It's fairly likely that you don't want a proxy connections to local hosts, so these two are fairly standard. This IP address here is the AWS EC2 metadata IP address. So what that means is if you spin up an EC2 instance and you start talking to this address, you'll actually be talking to like a web server that's been configured as part of that EC2 instance, and it exposes metadata information like details of the EC2 instance and its IDs and things like that. And so we also don't really want to proxy that, and so this is set up by default as well. Here we can see the configuration of these other objects. Octopus proxy, the address here has been set up, and that same proxy has been set up as the default proxy here. So you can see that the address is also the same, as well as the default proxy here. Address is the same. These two are empty because I'm actually running PowerShell 7, so these settings won't be set for me. And this is the end result of calling just a simple network request, which was this invoke web request here. And if we look in the access logs for Squid, we can see that the request to to this this address here did actually go through the proxy. So everything seems to be working as we expect. So the next one is then, if we look at this one here, it's the same script, but in this case we're actually running on a deployment target. And the deployment target here in this case is a tentacle that has been set up with a second web proxy. So if I run that one, that's going to be, actually I'll just clear this. Caught that in time. Let's have a look. No, I might try again. Okay, so that is the, again, that's the request to our internet address, the external internet address, and that's gone through the second web proxy that we've configured specifically on the tentacle itself, and it's not going to be this one here. So we can still see we only have the one log entry for the proxy that was set up on the Octopus server. If we go into the results of these, actually it's going to be this one here. Actually, so I should call out, there's two tentacles I've got running. This one here has the web proxy set up. This second one here doesn't have the web proxy set up, but it's set to, the tentacle itself is set to connect through a proxy. And so this is the result of the tentacle that has no web proxy. And as you can see, none of these settings have been set up. They're all empty. This is the tentacle that has a web proxy. You'll notice it has that second port number here, which indicates that it's going through that second Docker container. But otherwise, all the addresses have been set up as we expect, and the access has come out as we expect. This is actually the logs of the proxy that is used to, that is sitting in between the tentacle itself and Octopus. So as you can see, it's all its access logs are all about connecting back to the Octopus server, hitting the API and making sure that that all these API requests are going through. So there are a couple of things to watch out for here. One is, so you'll notice I've got an additional package reference here, and this has just been set up to download a package from a NuGet feed. But this setting here has been set to make sure that the package is downloaded by Octopus itself, not by the target. And so that's worked. That's fine. Octopus has gone ahead, downloaded the package on the server, and then distributed that through to the targets. But what happens if we actually change that setting and we go here and we say the target should download the package? In theory, this should be the same, right? Because we're using the same kind of proxy on the server as we are on the tentacles. They're both using Squid. They've both been configured in much the same way. But if we go ahead and actually run this, we actually get a different result, and this is going to fail. And so this has failed on the tentacle that was configured with a web proxy. We get this stack trace here, whereas actually it passed on the tentacle that had no web proxy. And so this shows you that not all code paths are necessarily the same. I haven't actually dug into why this didn't work. I was trying to look at it earlier, but ran out of time before we kick this off. But what you will find is that the code used in Calamari to download NuGet packages is not the same as the code used by a server to download the packages. And in this case, whatever that difference is, has been significant enough to cause this this tentacle here to fail and this tentacle here to succeed. So that's something to be aware of when you're looking at, when you try to diagnose issues with proxies, is that it is, or often will be, quite important where actions are taking place. Is it running on a server? Is it running on a tentacle? Where are the packages being downloaded from? Things like that can all play into the eventual end result. So the other thing to look at is, so far we've more or less been using either built-in Octopus functionality or PowerShell scripts. But there's a lot of other scripts, obviously, that are out there that people need to run. So this is a AWS CLI script. And we're actually just running a command with the AWS CLI here to get the details of the current caller. And so how this particular command line tool interacts with the proxy setup is very specific to the tool that's being called. And so in this case, the AWS CLI respects those environment variables, the HTTP proxy ones. And so if we go ahead and run this, what we should see are some requests through the proxy here out to AWS. Or maybe not. There we go. Okay, so we can see here that the AWS CLI has respected those proxy configuration settings and is routing traffic through the proxy here. And so we can see these network requests being made. Right, and here we go. So it did actually succeed, so that's all good. There's other steps. Azure has its own CLI again. So in this script step, we're running with the AZ command line tool. And again, we expect that to respect those environment variables and direct traffic through the proxy. Okay, there we go. So if we have a look back here, we can see again a couple of requests out to Microsoft services to deal with the Azure logins. So that's worked as we expect as well. Having said that, though, if we go into something like the accounts themselves and we test these connections, so that worked, but nothing came up here. So the code, actually I should try the Azure one as well. Oh, sorry, the AWS. So I test that one. Again, that's worked, but we don't see these same proxy requests. So there are paths in the application, in the Octopus application, that are not, in this case, again, I'd have to look in the code to find out exactly what's going on, but the lack of entries in these log files kind of suggests to me that testing AWS accounts and Azure accounts, they're not being configured with the proxy. So you may end up with a situation where people can create accounts and test them okay, but when it actually comes time to run a step, those steps may then actually correctly go through a proxy, and they may end up having a different end result. So this is an AWS S3 upload, and I think this one here also works with the proxy. So if we deploy that one, we should see some AWS endpoints being shown down here. Yeah, here we go. So so that script step did correctly configure itself to use the proxy and reach out. So what are the big takeaways from this for support? First is that Docker is really convenient for quickly spinning up a test proxy. And so running a command like this will get you up and running with a squid proxy exposing port 1328. If you do want to have the technical communication itself pass through the proxy though, you do just have to modify that config file. And so what I've actually done here, this executable command jumps into a running Docker container. I don't know if I mentioned that before. And I've called Vim here. Actually, if you want to use that, that editor though, you have to install it in the container. It doesn't come up by default. So that'll be just an apt-get update and then apt-get install Vim. And so that'll get you the text editor in the container. And then you can expose these additional ports here. So you get a test container. Things to look out for though are different code paths that Octopus takes depending on whether packages are acquired on the server itself or on the technical. And they may give you different results as we've seen. Certain code paths for things like testing accounts may or may not use the proxy. So that's something to be aware of, and that may be a red herring that you have to kind of navigate around when you're debugging an issue with a customer. The other thing that's worth noting that I haven't demonstrated here is that there's two different types of proxies typically. Squid just uses basic auth, but there's other Microsoft specific proxies that tend to use NTLM auth. Things like, I think there's an IIS application proxy, I think it's called, and that's significant. Those authentication methods may or may not be supported by command line tools. Like, I haven't actually tested it myself. They probably do, but the big cloud ones probably support NTLM. But other tools may not, and that's also worth paying attention to. What kind of proxy have you got? What kind of auth does it expect? Is it basic or NTLM? And that's something you'll have to take into consideration when dealing with proxies. So that's kind of the high-level overview that I wanted to run through for this particular workshop. Did anyone have any questions or wanted to go into any more detail?
No, that was good.
Oh, okay. All right. As always, I'll grab the recording and put it up when it's done. And thanks for joining in.
Cool. Thanks, Matt.
Right.
Have a good one.
See ya.
Bye.